Yay! Okay, so what I've got here, I've actually got an Arduino on here, although that's actually not the purpose of this circuit right now. What I can do, I suppose, is put it into it, and then you can see it change. But basically, there's an LM317 circuit, which is actually running from a 5V input. Okay, and I've got this meter across the output, so you can see the circuit. There's no capacitors on there. Normally you put capacitor in, but I've not got load, and the input is coming directly from a 5V regulated, essentially. So, oh, stop it. Right, so what I've done is I've got this guy's diagram here. There's a video from Afrotech Mods, and he's got an actual picture rather than a diagram, a picture, and you can see how he's got his resistor, his fixed resistor across the left hand pin and the middle pin. Okay, and then he's got, okay, so you can't see, but basically he's got a variable resistor here, which is from the left pin to the ground. Okay, and then the right pin is the input, because this wire here is a positive, and then that one's a negative, right? And so he's got that, and he's put a scope onto the output, which he's using. He's got a little wire going from this track. Turn the light off, and then it's not as bad. You can see just about that there's a little wire there. Okay, now he doesn't move his camera around and stuff, which is rather annoying, but basically you can see that this wire here, this one, give me a pointer, this one here that's going from there into that track is the one that he's got the probe on, so he's measuring the voltage for that. And then you can see this other wire that's going, if I can hold it around, I can't touch the screen because it'll start going, that one there, that is coming to the input from here, which is the positive. That's the positive wire. I'm not quite sure why he's using these, normally oxygen free wires, but there you go. So his positive here is going to the input pin, which is the right pin, which is this one. Okay, and then we've got the middle pin, which is that one there, which is connecting through here to his probe. And then we've got also that resistor, this one here. This resistor here is between this left hand pin and the middle pin. You can see the two pins there. Okay, and then here's his resistor, which goes to the ground here and connects to the left hand pin, which is in this track here. Okay, so that's how I've got it here. Let me just put the light back on. Oh, dear, now it's gone out of focus. Okay, so now you can see, if I can get in far enough. It's a bit difficult to see, right? So you can see I've got my control here. Move these wires out of the way a bit. That's it. Now you can see the track. So this part of it's not connected. Okay, there's no actual connection through to the board on this side. This one here is connected through to the left-hand pin. Okay, because it's on the same track. And then my resistor here goes to the middle, as you can see the middle track there, which is the middle pin. And then this wire here, the red one, is to the positive track. You can see the red, the positive track there. Okay, and this goes to the right hand pin, as you can see there. There it is in the track there. Okay, and so I can now adjust. Now the problem is as I adjust this, it tends to rip the thing out of the track because it's not really well put in. So I've got my 3.8, and if I change this, as long as it doesn't rip it out of the track, 1.20. Interesting, it's 1.20 and not 1.25. Okay, now that is where I've essentially cross-connected the ground to the left-hand pin. Okay. Oh yeah. Okay, let's just push it in place a bit. There. Now I'm not touching it, but if I move these wires around, it tends to, yeah, it needs a capacitor probably. So 1.23, which is the minimum voltage. Now we've got a 5V input, so we're not going to go very high. And I believe the formula is such that it should be 1.25 below the supply, which means it's going to be 3.75-ish. Okay, so if I turn this now to the other side, right, so that's maximum, which is, this is a 10k pot. The resistor here is a 220. And now we've got 3.8788. Now obviously it's not very stable, but then we've got open circuit output. So if I was actually going to do it properly, I'd probably put a resistor on the output just to give it a load. Yeah. What I'm trying to do is tune it, say, to 2 volts, or maybe 3. I'll tune it to 3. Hey, now it changes too quick, so obviously I need a different resistor here. Yeah, the pins are bending and stuff. It's not really very good. Okay, well, I'm trying to get to the point of where it's actually stable. Yeah, so things aren't changing. Now, I thought it was the LM317 that was not working correctly, but what it is I think when I did my first circuit, perhaps I got the pins the wrong way around, or in the board the wrong way around, something like that. I don't know, not sure. And I tried it this time around. It didn't work again, but it was because I actually placed things in the wrong track. So that's actually working, and that's a stable voltage reference. Now, how I'm going to use it, I don't know, but we shall see. And it doesn't really matter what the actual voltage is on this, right? If I'm feeding it into one of the pins of the ADC or using it to do a calibrated measurement, as long as I know what the voltage is, that's irrelevant, right? I just need to know what it is. And I would tend to put it in somewhere in the middle of the range, so about 2.5 volts, which is roughly where it is now. Now you can see that meter isn't moving very much. We've got this third digit moving a bit, but that could be just the hysteresis of the meter itself or the measurement. Okay, so that seems rather stable. Okay, but I don't know. And so what we need to do now is put that onto an ADC and see what the ADC reads out. The other part of it is that the ADC itself, the ADC circuit of the Arduino, can take an input as being its reference voltage, which basically is the maximum voltage that you can go to on the ADC. And I think they have an internal reference of 1.25 volts, which is, to me, I'm trying to avoid because it's a bit low. Okay, so that means you have to measure everything between 0 and 1.25 volts, which means you have to use more external components, which will increase the inaccuracy that way, I'm assuming. I don't know. Okay, and then the other side of it is that if I actually use this as input, as a stabilized input, yeah, then it's actually changed, doesn't it? I don't know. Anyway, but the point I made is that the LM317 obviously works, and that I'd messed up. I couldn't understand why it wasn't working. Anyway, so there you go. And I think also before I put a resistor in which I'd actually got wrong. That when I was constructing the circuit, I think this resistor here, this is a 220, for some reason I pulled out a 220k or something, which is not going to work. There's not enough current. So I don't know. Anyway, this works, and I'm really happy about that because it's picking up past 10 at night now and I want to go home. So there we go. Yeah.